Supplemental math videos from Circle Christian School. Okay, this is the third in the series of chapter 6 let me think, 3 and 4. Adding rational expressions and ditching the demon. Today, or on this one, we're going to ditch the demon. Okay, so the first thing we're going to do is have everybody be a fraction. So we got a 1 here, just like that. And since we're going to ditch the demon here, I'm going to find a common denominator between 6, 1, and 12. So your common denominator is going to be 12. So we're going to multiply the first guy up here by a 12, and the next guy here by a 12, and the last guy here by a 12. We're going to cut things out. That's the whole thing behind ditching the demon here. Use our Diablo saw blade. So 6 goes into the 12 and leaves us with a 2. And just doing the math, that's going to give us a 2x minus 6. And this is a negative 7 here. So we have a negative 12 times the 7, or you can say 12 times the negative 7. Nothing's getting ditched because there's a 1 down below. Is a 4, and put a 1 up here. Gives us an 84, so a negative 84. And these are going to get ditched right there. And that leaves me with an x. Okay, so that's going to be 12x minus the 90 equals an x. I'm going to minus 2x, and I'm going to minus 2x. Alright, you might be able to hear the helicopter go by. And that's a negative 90 equals a negative x. So x equals 90. Let's put it back in and see if we get a correct equation. So we have 90 minus 3 over the 6 minus the 7 should equal 90. Oh, 90 over the 12. Now I'm liking it better. Okay, so we have an 87 over 6 minus 7. Okay, so this is just all a check, so we're just making sure that it actually does work out. So we have a 90 over the 12. Best way to play with this is you can use your calculator. That's fine. You can turn everybody into a decimal and play that way. I'm going to work on common denominators. And so that's going to give me an 87 over the 6 minus a 42 over the 6. And again, does it equal a 90 over the 12? Which actually can get reduced down, so we can make it be a 6 too. But I'll get that in a minute. So 87, take away 42. Is a 45 over 6. And does that equal 90 over 12? Well, half of 90 is 45. And half of 12 is 6. And we go, yes, we're correct. And a round of applause. Okay, let's go to the next one. Again, we got to look for a common denominator between the 3, the 2, the 6. It's going to be 6. Going to multiply everybody by a 6, the common denominator. Going to ditch that demon. Times the 6 times the 6. Okay, so now we're going to do some ditching of the demon. 3 goes into 6, gives us a 2. And that leaves us with a 2x squared. 2 goes in the 6 and gives us a 3. Gives me a plus 3x equals the 6 ditches the 6 and a 5. And we have to look at these and go, oh my golly, I have to still go find x. So take a look here. Boop, boop. I'm quadratic, so I have to set everybody to 0, the 0 vector property. No, it's the zero product rule. Anyway, got to set everything to 0. So we get a 2x2 plus a 3x minus a 5 equals a 0. Oh, Jwaz, we have a number up front. Always make sure that you can't GC fit it. 2, 3, 5. No, so we're going to have to factor by grouping. Factor by grouping. We need factors for a negative 10. Then when we add them together, equal the guy in the middle, the positive 3. Oh, 2 and 5. Liking it. Okay, the big number carries the sign, so it's a plus 5 and a negative 2. Going to branch them down. So we have a negative 2x and a positive 3x. Okay, all I can tell you is that if you're not liking this, you really, really, really needed to listen to Mom and practice those multiplication facts, mental math, adding and subtracting. It is so key here. If you got younger brothers and sisters and you didn't do it, make sure you tell them that they have to learn their multiplication facts. It is just necessary. Okay, so the first group here, we can take a 2x out, divide out a 2x. It's a common factor. Going to leave us with x minus the 1 plus, you always have to take something out. Oops. Oops. Oh, don't tell me I have to do this again. That doesn't equal that. It's supposed to be a 5. Oh, okay. Okay, you should be screaming at me by now because this should be a 5. Okay, now how did I discover that I had made this giant little boo-boo here? Well, it happened because I know that when I factor the second group here, we have to have those twins, okay? We have to have those twins. And I was discovering that when I started factoring something out here, I was not going to get my twin. So we can take a 5 out. X minus the 1. And so our first binomial is our twin. The second is the leftovers, 2x plus the 5. We're going to set both of those to 0. X minus 1 equals 0. And 2x plus 5 equals 0. Why do we factor? We factor so that we can go find x. So the first x is going to equal opposite sign, a positive 1. And the second x is going to equal opposite sign, so a negative 5 over the first guy. If you don't believe me, go ahead and put your fence of equality up and solve it. And those two answers would be correct. Okay, the first two were pretty cool because we had all numbers down in the denominator. Now we've got some variables down here, and what I'm going to tell you is the common denominator is really as simple as you just need one of each thing that's there. So we have an x and we have a 3. So our common denominator is a 3x. So what we're going to do is multiply everybody by a 3x so we can ditch the demon. Multiply it by a 3x. Remember, if any of this seems kind of fast at any time, just go back and listen to it again, and listen to it again, and listen to it again, because that just affords you a little me sitting there with you doing your homework or practicing things out. Okay, so I can ditch an x and an x, and it leaves us with a 3 times 7, minus sign, 3x, 3x, and a 1. A 3 and a 3 and an 8x. And we end up with 3 times 7, or 21, minus the 1 equals the 8x. That's going to give us a 20 equals the 8x. Now we're going to divide by the 8. Divide by the 8. Nice little linear equation. So x equals 20 over 8. However, what you always have to remember is all fractions must be reduced. They must be in lowest terms. They must be simplified. Three different ways to say the same thing. Okay, so we have an even number and we have an even number. Greatest common factor between 8 and 20, 2, 4, 4. So 5 over 2 equals x. Second thing I'm going to tell you is that because you began with all these fractions here, it's just almost a sure bet. You have that occasional one where it comes out even, but it's almost a sure bet that you're going to end up with a fraction as an answer. Okay, next one. Okay, we got x's up top, we got x's down bottom. Yes, we could use a common denominator, and I'm just going to write it over here just for the sake of practicing finding a common denominator. Remember to take all your binomials, put them in parentheses. Keeps everybody happy. One of each. Common denominator would be x plus 4 and x minus 1. Now, yes, it's very true. You could actually ditch the demon, multiply everybody by the common denominator. But since this is a fraction equals a fraction, cross multiply. So we get 2x times x minus the 1 equals 3x plus the 4. And now we're back to a regular fun little equation. Let's distribute. Combine some like terms. This is going to give me 2x2 minus the 2x equals 3x plus the 4. Are you seeing it already? Okay, jump up and down if you saw, hey, it's a squared guy, so we got to let everybody equal 0. This guy's going to have to jump the fence. This guy has to jump the fence. And what happens when everybody jumps the fence? They change their signs. So we have 2x2 minus the 2x, he didn't jump, minus the 3x minus the 4 equals 0. See, we changed the signs. Okay, so we get a 2x2, a negative 5x, and minus a 4. Cool beans. Okay. Because this guy is a 2, we're going to have to see if we can't pull out a greatest common factor. No. And that means we're going to have to factor by grouping. Factor by grouping. So I need factors for A times C, a negative 8, that when we add them together equal our B, the guy in the middle, a negative 5. Did I do something wrong? I did. Uh-oh. Let's see. Can you find it? Can you find it? I told you. Even when I'm at home, I have to do these little arrow things. Oh, gee whiz. My bad. Hopefully you were screaming at that one too. Big Ben. A 12. I should make it big because it's a mistake anyway. Okay, so this is a negative 12. I don't know if that's going to make it any better or not, to tell you the truth. I may have to do la 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 la. Okay, let me see here. Oh, You jump the fence, so it was a negative 12. Oh, factors for a negative 24. Okay, I see it now. That give me a 5. That makes much better sense. But see, it's knowing those rules about these quadratic guys to begin with that let you know, well, that just is impossible, Mrs. Washington. It's just not going to work. And now I see that I've got the 8 and the 3. Oh, those are so much friendlier. The big number carries the sign, so that's the negative, that's the plus. Make our little branch down. Branch. So I get a negative 8x and a positive 3x minus the 12 and the 2x squared equals to 0. Going to do some factor by grouping. Group, 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 group. Okay, so we're going to factor out. First group, I'm going to factor out a 2 and an x, which is going to leave me with an x minus a 4. And the next group, we can factor out a 3, which is going to leave me with an x minus 4. See, there's my twins. So we end up with 2x plus 3 times x minus 4. We're going to set each one of those to 0 so that we can find out x of the first guy, opposite sign over the first one, and x equals opposite sign and a 4. Make sure that when you do a whole bunch of work, I'm kind of limited in my space here, but when you do a whole lot of work, just make sure you circle, notate, neat little things so that you can see, hey, that's my answer. Those kind of things. Okay, something bigger. We don't have a fraction equals a fraction, so we can't do that little cross multiply. But again, we're going to make everybody be a fraction. We're going to take everybody who's a binomial, put them in parentheses, and sometimes to find a common denominator, what we have to do, just like when we were adding our rational expressions, we have to factor to find out what all the common denominators are going to be. And so underneath the 12 here, we see our really cool difference of two squares, our little 2-second problem. Okay, so our common denominator is we have a 1. And we really don't have to mess with them all that much, but just so we can see it, we have an x plus 1. And we have an x minus 1, one of each. So that's our common denominator. So I'm going to multiply everybody by an x plus 1 and an x minus 1. And I kind of do this little angly thing because I know I'm just going to start ditching things. The second guy, x plus 1, x minus 1, and the last one, an x plus 1, and an x minus 1. Okay, let's do some ditching. Goodbye, goodbye. Leaves us with 3x times x minus the 1, equal sign. Ditch, 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 ditch. Leaves us with a 12. And the 1, that's obviously going to leave us with a plus 2. So there's our plus 2 times the x plus 1, the x minus 1. Okay, let's distribute. So this is going to give us a 3x squared minus a 3x. Starting to look a little quadratic. 12 plus, I'm not going to do the 2 yet here because I'm going to FOIL these guys out, which we know equals x squared minus 1, that little difference of two squares, that little 2-second problem. So we end up with 3x squared minus the 3x. Yes, I'm sorry. You have to write. You have to do the process. Do things step by step. Keeps integers happy. Keeps the teacher happy. Keeps the math problem happy. Okay, so we're going to take this. Let me bring it back up here for the sake of space. And so we have a 3x squared minus a 3x. I'm going to jump the fence here because I know it's quadratic and I'm going to have everybody equal 0 here. So I have a negative 12, a negative 2x squared. Everybody's jumping. Plus 2 equals 0. They jump, they change their sign. Got to combine our like terms. Okay, so we have a 3x squared and a negative 2x squared. So that's going to give us x squared. We only have one x, so minus 3x. And we have a negative 2 and 12, sorry, and a positive 2. So that's a negative 10. Oh, it works. It looks good. Okay, this is a nice double bubble because 1 is sitting up front. So we know this is an x and this is an x. And we need factors for a negative 10 that when we add it together equal that negative 3. 5 and 2 seem to kind of work. Big number carries the sign, so that's a minus, that's a plus. And so x here is going to equal opposite sign, positive 5, opposite sign, negative 2. Cool. All right. So why do we do this? We do this so we can do fun with little word problems. One of the most favorite ones happens to be a work rate word problem. When two people have to work together. So you and your best friend are going to paint your room a vibrant red, white, blue. You've painted the same room by yourself in 5 hours. Your friend has done it in 7 hours. Working together, how long will it take you to paint the room? Okay, let's use a little bit of the buck system. The first thing that you're going to do is, what is the question? Box out the question. How long will it take you to paint? All right. Important information. Let's see. Painted. You painted in 5 hours. Your friend has painted in 7 hours. Working together. All right. The next thing that we're going to do is look for mathematical things. And we have 5 hours. 7 hours working together, so we got a plus sign. Knock out unimportant information. Yeah, we probably really don't care about this. And that it's red, white, and blue, to tell you the truth. Just sounds nice. Okay, let's put some things together. Okay, so what you have to do is think hourly when you work a work rate. Think hourly. And so basically, what happens here first is, okay, so you got to think hourly here, which means that if in the first one here it takes you 5 hours, then how much work have you done in the 5 hours in 1 hour? Well, basically what you've done is 1/5 of the job. And then your friend has done 1/7 of the job in 1 hour. And it all equals 1 job. Okay, now, actually like this looks kind of like a fraction kind of thing. So yeah, you can do a little ditch the demon. I was going to do ditch the demon anyway. A lot of times you'll see the T over the hour. So you can have it off to the side here or over the hour. We got 5 and 7, so we're going to just multiply everybody by a 35, just so we can ditch the demon. Alright, so 5 gives us a 7T. 35 is going to give us a 5T. equals one job, which is 35 over 1, so 35. So that gives you 12t equals the 35. And so it's going to be 35 divided by the 12 equals the t, which would be, gee, almost 3 hours for both of you. So you can almost say almost 3 hours, 12 into the 35. But if you want to be really, really, really exact, then it would be 2 hours with something left over. Oh, gee whiz, let's just do it the easy way, by the calculator. So we have a 35 divided by the 12. Let me make it a fraction. Well, it already is a fraction, so I don't know what I'm thinking there. So 24 minus the 35, 11. Okay, so I'm actually going to change this into a fraction. And, oh, hold on a sec, that's son number 1, the ugly one. Okay, to finish this out quickly, it's the same thing as 11 over 12. And if you break a clock up into 12 parts, it's 5 minutes. So it really means 2 hours and 55 minutes. If I were you, I'd be painting with your friend.